So in this video we continue with motion in one dimension. We had already completed the two parts, that is part 1 which was about the motion one dimension, the general terms, and the second part which was based on the graphical representation of the linear motion. So that two parts we already completed. We come to the third part now, which are nothing but the equations of motion. So the next part over here is equations of motion. Now this is a very important part of this particular topic for two reasons. First reason is you are going to derive three equations of motion. The three equations of motion, both the things, the learning of both all the three equations, compulsory, very important. And secondly is the derivation of this particular equations. See, the derivation is of two kinds, both the kinds we are going to see now, and that complete derivation is important as it is normally one of the favorite questions of the teachers for about 3 to 4 marks. So you need to understand the complete derivation, you need to know how to derive it and learn it properly. And of course finally is the numericals based on the three equations what we are having. So in this way, this particular part of the chapter is absolutely very important. So the derivation of the equation of motion are of two kinds. One is the graphical method. So first one is graphical, and the second method is by definition. Okay, that is the definition method. So the graphical method and the definition method, or the alternative method, that is the definition method, are the two methods by which we are going to derive this particular three equations. So before we start with that, we will need for a graphical method. So we'll start with the graphical method first, and we will first of all draw a graph. So the graph what we'll be drawing over here will be a velocity time graph. So it will be a velocity time graph where the time will be in seconds. This is the x-axis, this is the y-axis, this is meter per second. So accordingly this is velocity in meter per second, this is time in seconds. We'll take 2 points over here. One point we'll take it as v, small v, another point as small u. Okay, and accordingly we will be having a line like this, such that this is corresponding here. So this is 0 and this particular point is time t. Okay, so we see over here this particular, the coordinates of this point if I see will be equal to 0 comma u, and this particular point will be t comma v. Okay, this will be the coordinates of the 2 points over here. So this is the graph. So it is telling us, what does the graph tell you over here? That a body was already moving. When you started to watch that particular body move, you found that the speed at which it was moving was u, and in t time seconds its velocity increased from u to v. So that is how you are having this particular graph over here. Now, so the first thing what comes up in our mind is finding out the acceleration using this particular graph. So if I see the acceleration over here, we know that acceleration is given by the slope of the line. So slope is equals to acceleration is equals to y2 minus y1 upon x2 minus x1. This is my x1 y1 and this is my x2 y2. So accordingly it is y2 minus y1 is v minus u, that is a is equals to v minus u upon t minus 0. Okay, this gives me as a is equals to v minus u upon t, or I can say that at is equals to v minus u, or we say v is equals to u plus at. This is our first equation of motion, that is v is equals to u plus at. Did you understand this one? Very easy. We are just finding out the slope and we took the values of the y2 and y1 from this particular line. Accordingly, we have this slope as v minus u upon t, or at is equal to v minus u. That is u coming here, it becomes v is equal to u plus at. So this is the first formula of, or the first equation of motion, v is equal to u plus at. Now we move forward. The next thing is that I know that the area enclosed over here will be giving us the, what does it give you? Displacement. Okay, so the area enclosed gives the displacement. So we have over here that displacement S is equals to area of trapezium. It is a trapezium which is formed over here. These are two parallel sides, and this is the height over here. From here to here is the height. These are the two parallel sides. So S is equals to, area is equals to half into parallel sides. So sum of parallel sides into height. So that is nothing but 1 upon 2. Now, what are parallel sides? Over here, this distance is u and this distance is v. So it is u plus v into h over here is t. So it is t. So that means S is equals to half v plus u into t becomes my next equation, but it is not the equation of the motion, but it is an equation which is going to help us to find out the second and the third part of the motion. Okay, one second. So this S is equals to 1 upon 2 v plus u upon into t is a very important part of our derivation, because by this particular thing we are going to derive the other two derivations. Okay, so other two equations are going to be derived using this one. So now, so this becomes a very important thing. Now what we have got over here is v is equal to u plus at. So let's replace this thing v over here by u plus at. So you get over here S is equals to 1 upon 2, v is nothing but u plus at plus u into t. Why is it so? Because it is v is equals to u plus at. That is the equation what we already got over here. So we are just replacing the v by u plus at. This thing over here is because of this thing over here. Got it? So S is equals to half. Now u plus u is 2u. So it will be S is equals to 1 upon 2 into 2u plus at into t. Okay, let's not multiply inside. You can have it over here. This is as 1 upon 2 into, not required, it's 2ut plus at square. Now take the inside, half inside, so it will be 1 upon 2 into 2 will be 2 cancel, so ut plus 1 upon 2 at square. This is the required equation number 2. So the equation number 1 is v is equal to u plus at. Equation number 2 is ut plus half at square. S is equal to ut plus half at square becomes your second equation. Are we clear on this? We move on to the next thing. Now over here, let's find out what is the value of t from this point. Okay, from this value, what will be t? So we have over here t is equals to, see here itself, t will be equal to v minus u upon a. So it will be v minus u upon a. Right? This is from the equation, this part. So this is, we know. Now let's put the value of t in this thing. So it will be S is equals to half into v plus u into v minus u upon a. So this is a plus b, a minus b. What is a plus b, a minus b? A square minus b square. So there it will, S is equals to 1 upon 2a v square minus u square. Got it? Because this is multiplication, 2a comes here and this is v square minus u square. So 2a when it goes here, it will be 2as is equals to v square minus u square. Hence, v square is equals to u square plus 2as. That's the required equation number 3. So the three equations of motion are first one over here. This is the first one. V is equal to u plus at. The second one over here, s is equal to ut plus half at square. And the third one over here, v square is equal to u square plus 2as. This is how you are learning, or you are able to find out, or you are able to derive the three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2s. Now remember that this was possible only by this equation, which is actually not the law of equation of motion, but very important, because this, with the help of this, we framed everything. So s is equal to half u plus v into t is another very important equation over here. Okay, so this was how you derive the equation of motion by graphical method. Now the question could be specific, that derive the equation of motion by graphical method, or it could be just derive equation this by graphical method, or equation this by graphical method. In that case, you will need to do all these up to this point. If it has only this, you do only this much. If it has this one, then you only do this much, and this one will be not required to be answered. Okay, so it will depend upon what is the question asked to you. If the question asked to you is only this, then you take only this much part after you complete this part. And if it is this, then you take from here all the way up to this point, and then just from here to here. Am I clear on this? So this is how we are going to do these sums, or to do the derivation of the equation of motion by graphical method. Now we go to the next part, and that is the definition method. So let's go to a definition method now. So in the definition method, we are going to have the definitions of both these things. Okay, so we will have the definitions of, so first definition. What is the definition of acceleration? What is acceleration? Acceleration is change in velocity upon time. Okay, rate of change of velocity by time is acceleration. So we know over here that acceleration is equal to change in velocity upon time. Now if I am talking about change in velocity, it is nothing but v is my final velocity, u is my initial velocity. So that's why it is a is equal to v minus u upon t. Did you get it clear? So it is basically, first of all write it in a proper form: final velocity minus initial velocity upon time. That is why a is equal to v minus u upon t. Hence we have the same thing as we did earlier. V is equal to u plus at, because t goes here to at and then u comes here to plus. So this is the first equation. So the first equation is v is equal to u plus at by this particular method, that is final velocity minus initial velocity upon time. That is nothing but v minus u upon t. The next thing is distance traveled. We had the distance traveled. So over here, distance traveled is equal to average velocity into time. See, the distance traveled will be the average velocity into time. Now here the average velocity is nothing but the sum of observation into number of observations. So it is nothing but s is equal to final, or we can say initial velocity plus final velocity upon 2, that is the average velocity, into time. Okay, so this is u plus v upon 2 the whole into t. Right? If you see carefully, you will find that this and this is one and the same, because this can be written in s is equal to 1 upon 2 v plus u into t. This is the same as this one. Got it? So we got the first equation, we got the intermediate equation over here, which is very, very important. Accordingly, I don't require this part, but then whatever is the derivation required for the second equation and the third equation remains the same, because what you are going to do now, you are going to take t as from here. What you are going to take t will be equal to, sorry, v will be equal to u plus at. So here v becomes u plus at. Okay, so we have over here s is equals to 1 upon 2 v plus u into t. So v is nothing but u plus at. Okay, u is equals to u plus at. Hence you get this equation. Similarly, t over here becomes v minus u upon t. So this is the part. T is equals to v minus u upon t, and you replace the t of this by the same thing. Got it? Accordingly, you have the third equation as v square is equal to u square plus 2as. So you see that by using the definition method also, we had to learn what is the difference in what we did in case of definition method and graphical method was that in definition method we use the definition to give you the first equation and this intermediate equation. Rest all is the same. In graphical method we here use the slope of the graph v minus u upon t as slope of the graph, and then we use this as the area of the graph. So this is what we found out by graphical method, the same thing over here, and then you are doing this. So this part is common for both the methods. Accordingly, when you learn this thing, this is the only part which is very important because it is common in both of them. Whereas this thing you have to understand properly. It is quite easy to understand because it is based on a proper logic. First one was based on the graph. So slope malum hai, y2 minus y1 upon x2 minus x1, and you also know the area of the trapezium is half into sum of parallel sides into height. So accordingly you got these two things. Here definition you know is change in velocity is final velocity minus initial upon time, whereas distance traveled is average velocity into time. Okay, so average velocity is initial velocity plus final velocity upon 2, hence we get the answer as half v plus u into t. Is it clear? Have you understood this properly? Okay, now the same equation. So here, okay, let's go through the equation once again and then we can say something special about these equations or special kinds of cases in this kind of equations. So we see that the three equations of motion are, first one is given as v, first is v is equals to u plus at, second is s is equals to ut plus half at square, and the third one is v square is equals to u square plus 2as. Now we'll see two special cases. Case 1 is when the body starts from rest. Okay, body starts from rest. That means my u is equals to 0. So what will happen to the equations if my u becomes 0? We know that it will be v. So the first equation will be v is equals to at. Second equation will become s is equals to half at square, because this is 0. This is 0, so this term becomes 0. So s is equal to half at square. And lastly, third one is v square is equals to 2as. Understood? So we find over here that in special cases, this will become like this. Now, we will not learn these special cases by heart. It is not required. It is not required. Why is not required? Because when you are given a sum, you already know that if it is coming from rest, u is going to be 0. So you are going to use the same and put that 0 rather than learning this as a separate thing. Okay, so we will not learn it as a separate thing. We are just going to see to it that these values we are able to get when we take v is equals to 0. And the second thing is that when the body is having a uniform retardation, A will be negative, means when the brakes are applied. Okay, if the brakes are applied and then the body is going to have a retardation taking place, so that means my A will be negative. So it's the second case. So the second case B is when retardation of body. Okay, so that is A is negative. In this case, what will happen? The first equation will be V is equals to U. Now, if this is minus, it will be minus AT because A is negative. So plus minus minus हो जाएगा. Second thing will be over here. S is equals to UT minus half AT square because A is negative. So this becomes minus. And the third one is V square is equals to U square minus 2AS. Okay, that will be the condition, special condition for any body which is retarding. We have got one more option over here which is not given in the textbook initially over here, but it is important and we can easily derive it also, and that is when body freely falling. Okay, when the body is freely falling, at that time what happens? So we will take A is equals to G and S is equals to H. Okay, in this case what is going to happen is against gravity, it is with the help of gravity that it is falling down. So A will be G and S will be H. Accordingly, you have the equation as V is equals to U plus GT, and second one will be S is equals to UT plus half GT square, and third will be S is equals to, sorry, V square is equals to U square plus 2GH. Here it will be H. Okay, that will be the condition. Obviously, if this would be freely falling downwards, if this is downwards, this is down. If it is thrown upwards, then what would happen? If it is thrown upwards, then G becomes negative. So in upwards, up direction, it will be is equals to half U minus GT. This will be equal to, H will be equal to UT minus half GT square, and will be equal to U square minus 2GH in case when the ball is thrown vertically upwards. If when I am throwing it upwards, at that time what is happening? When it is going up, at that time gravitation is going to be negative work done by the gravity. The work done by the gravity will be negative because it is going against it. Then it is going to be this way. Okay. Moreover, you get to know this thing much easily when you are going through the numericals of this thing. So anyway, I'll write it properly over here. So this is V is equals to this much, H is equals to this much, and over here V square is equals to this much. Okay. So these are the equations of the motion what we are talking about. These are the different equations of the motion, and that is very important for you to learn these things properly. You need to understand it properly. You need to learn the derivations properly, because only when you understood this properly, the numericals what are there given over here become easy for you to solve. Otherwise the numericals are going to be slightly difficult because you will not understand which formula to be used at what particular instance. So that was about the equations of motion. Right, and we'll continue with the numericals in the next video.